Okay, we've been working really hard in class on sig figs and trying to wrap our mind about God, how many sig figs does this number have? And, I don't know, and we're working hard, so we got to add math to it, which is a simple step. What happens when we multiply and divide using numbers in the laboratory using significant figures? Well, it's pretty simple. We got to figure out how many sig figs there are in each number that we're multiplying. So we can do that. We've been practicing that. You guys are getting really good at it. The answer cannot contain more significant figures than the numbers being multiplied or divided with the least number of significant figures. Well, okay, that's in words. What does that mean? Well, let's go ahead and let's do an example here. Let's take 6.30 times 17. 6.30 times 17. Now, what we have to ask ourselves is how many sig figs, excuse me, how many sig figs does 6.30 have? Now, 6.30 is kind of a tricky one, but it has 3. How many sig figs does 17 have? 2. What this multiplication and division rule says is that our answer cannot have more than 2 significant figures. So when you take 6.30 times 17 in your calculator, the number you end up getting is 107.1. 107.1. Now, how are we going to make that into 2 sig figs? 107.1. Well, you have to make the number into 2 sig figs, and you kind of are going to have to round up or round down. And if we have 107, are we going to round up or down? We'll round up to 110. So our final answer here would be 110 because 110 has 2 sig figs. The least amount of sig figs that we had was 2. Let's do another question. Let's do a division question this time around. Let's take 14,100 and divide it by 4.355. How many sig figs does 14,100 have? It has 3. How many sig figs does 4.355 have? It has 4. What is our least amount of significant figures? Ding, 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 ding. 3. So now our answer has to be in 3 significant figures. So again, we're going to go into the calculator and we're going to go 14,100 divided by 4.355. And the number it gives us is 3,237.6. But our answer needs to be in 3 significant figures. So what number could we round 3,237 to have 3 significant figures? We would round it to 3,237. 37 is going to round up to 40. 3,240 has 3 sig figs. Our answer has 3 sig figs. We're good to go. We will spend time on this. The math part takes a little bit of extra time to do, but we will spend some time on this as we get used to using sig figs because they're a huge part of measurement in lab. The other part that's a huge part of measurement in lab is scientific notation. Why do we have to use scientific notation? Well, it helps us explain really large numbers or really small numbers very, very easily. For example, let's say I have the number 0.000000000076. Am I going to want to write 0.000000000076? No, absolutely not. How is it? It is easier to write it as 7.6 times 10 to the negative 11. So it's a way of making numbers cleaner and easier to write when they're really large or they're really small. Now, how do we do this? Well, first things first is the number in scientific notation must always be between 1 and 10. That's our first step. So our number has to be between 1 and 10. So 50,000 will be written as 5 times 10 to the 4th. So something like that. Example, 0.314 can be written as 3.14 times 10 to the negative first. Now, how do we do this? So let's go back here and let's do an example. All right, let's erase this. Let's do a couple sig fig examples. Or sorry, not sig fig examples. Let's do a couple examples using scientific notation. And how do we put numbers into and out of scientific notation? My eraser's taking forever here. All right, let's use the number here, 64,000. I want to put 64,000 into scientific notation. Well, it's pretty easy. I'm going to move the decimal until I get a number between 1 and 10. So my number's got to be between 1 and 10. So my decimal is right here. So I'm going to keep moving. 1, 2, 3. No, my number 4. If I make my decimal now is 6.4. That's good. Now, how many times did I move my decimal? I moved it 1, 2, 3, 4. So I'm going to go 6.4 times 10 to the 4th. Anytime 6.4 times 10 to the 4th. Anytime I have a number bigger than 1, my exponent, my number will be positive. Anytime I have a number smaller than 1, it'll be negative. So 64,000 is definitely larger than 1. So that is why I'm going to have a positive 4. Let's go ahead and do another example. 0.0000708. Let's write this in scientific notation. Well, again, I'm going to move my decimal until I have a number between 1 and 10. So let's go ahead. 1, 2, 3, 4, 5, 6. I moved my decimal 6 times. When I did that, my number is between 1 and 10. My number is 7.08. How many times did I move my decimal? 6. But now my original number here was smaller than 1. When it's smaller than 1, we have a negative exponent, 7.08 times 10 to the negative 6. Right. How do we do in reverse order? Let's do it in reverse order. Well, let's take a number like this. Let's go 5.6 times 10 to the negative 4th. I want that as a real number. 5.6 times 10 to the negative 4th. Well, we already know what? When it says times 10 to the negative 4th, we know that the number is smaller than 10. Or excuse me, smaller than 1. It's smaller than 1. So, it's negative 4. We have to move the decimal 4 times. Which direction are we going to move it to make this number smaller than 1? We're going to move it to the left. So when we do that, we go 1, 2, 3, 4. Just like when we are converting metric systems, I fill in all my wells with zeros, and my answer ends up being 0.00056. We do one last and final example. Let's go 8.85 times 10 to the 5th. 8.85 times 10 to the 5th. Well, right now we know that times to the 5th, it's a positive number, so this number is going to be larger than 1. All right, larger than 1, so we're going to move the decimal to the right. And we're going to move it to the right 5 times. So when we do that, we're going to go 1, 2, 3, 4, 5. Fill in with these zeros, and my answer this time ends up being 885,000. So we will work a little bit with sig figs. We'll work some time with sig figs, and if you have any questions, make sure you come in and ask, because we have a test that's upcoming shortly, very, very quickly.